Hi friends, welcome to my YouTube channel Physics Jagat, a small step to explore the gigantic world of physics. As we have seen yesterday in previous two lectures that what is charge. Okay, now we are going to discuss the properties of charge. We know that there are two properties of charge. What we have learned so far, that positive and positive charge, they are repel each other. Negative charge, they are also repel each other. But positive and negative, they will attract each other. That is one property of charge. Apart from this property, we are going to discuss some more property of charge. But before that, I want to say few more words about charges. Okay, if I take a system of two charges, okay, system means you can take plastic, whatever, plastic, fur, okay. If I may take one plastic rod, okay. Now generally in plastic rod, it is not possible that it has only two charges. There are more than two charges, okay. But it is assumption that if I take system of two charges and the size of these two charges, remember the size of these two charges is very small compared to distance between them, okay. Size of these two charges is very small as compared to the distance between them. Then these two charges will be considered as a point charges, okay. Point charges, okay. Another property of these point charges is that the charge of this point charge, this point charge is concentrated on point, okay. From far apart, you may say that this is very. Now we are going to discuss first property of charge, the additive charges. What is additive charge? If I have a system containing two charges, say Q1 and Q2, okay. First charge is Q1, second charge is Q2. Then the entire system, the charge of the entire system is equal to Q is equal to Q1 plus Q2, okay. If I have one chalk in my one hand, second chalk in my second hand, okay, and these both hand will become a system, then the total chalk of the system is 1 and 1. 1 plus 1, that is 2. Same attributed to charge as well. If you have two charges, the total charge of the system will be algebraic sum of its constituent, okay. If you have n charge, similarly n charge, the total system is algebraic sum of n charges, okay. That's why it is a property, that is additive property of charges, that charge of the total system is algebraic sum of its constituent, okay. So that means what? Charge has magnitude, but it has no direction. It has no direction. That means what? Charge is scalar quantity. Charge is scalar quantity, just like mass. But there is a basic difference between mass and charge, that mass is always positive, and we know that charge is either positive or negative, okay. That is a basic difference between mass and charge. Mass is scalar and charge is also scalar. This way one can do addition of charges, okay. So this is the first property, and very basic property and very important property of charge, okay. Now we are going to discuss second property. Second property is somewhat we have seen in the past two lectures also. Second property is conservation, charge conservation, or charge is conserved, okay. I've told you that charge is neither created nor destroyed, okay. When we rub plastic with wool, okay, this is say plastic rod, okay, this is plastic rod, and you rub with silk or wool, whatever, what happens? Say charge from silk to plastic to silk, charge is transferred, Okay, so what happened? One system. So what happened? Plastic is losing charge and silk is gaining charge. Okay, one becomes positive, second becomes negative. That we have seen, but it does not happen that in the silk it accepts charge. It does not happen from silk. In silk, that is, charge is created from nowhere. It does not happen. And similarly here also, in plastic also, charge is disappear from plastic. It does not happen. Okay, charge is just transfer from here to there. Okay, charge is not lost in the universe. Okay, so this is charge conservation that we have seen in the previous lecture. In isolated system, say in n number of charges are in isolated system. So in n number of charges there are interaction between charges, but it does not mean that it creates in the system or destroy in the system. Charge is always remain conserved in the isolated system also. One more example that I want to give you about charge conservation is, say, neutron. As you know, in our atom there are orbitals of electrons. Okay, and in the nucleus, in the center of the atom we have nucleus, and nucleus has equal amount of proton and neutron inside it. Here proton and neutron. Okay, that means nucleus have positive charge and electron, negative charge electron, is revolving around it. This is the very rough idea of atom that you know. Okay, now what happens in the nucleus only we have neutron also. So neutron is having a charge, means neutron is a neutral charge. Okay, neutron is chargeless. Okay, that means we can say neutron is chargeless. Okay, that's why I have mentioned 0 only. Okay, now neutron is emit proton and electron. Now you see, proton is positive charge, electron is negative charge. Okay, and neutron is negative, and these two, proton and electron combined, they will form a neutron. So it does not mean that system, and in this process also it never happen that if neutron decay into proton will fly apart and electron will also fly apart. They will form in the system only. If you combine them, proton and electron, they will become neutral. So this is charge conservation also. So friends, today we have seen two properties of charges. Okay, now on that note I finish my lecture. If you haven't subscribed yet my channel, then please subscribe it, share to your friends this video, and like. Okay, if you have any comment, please comment down below. Okay, thanks for watching my channel. Thanks you.